Welcome back. Welcome back. Welcome back. This video, the students, just communicated to me that they're looking for certain kind of video in which, they should be knowing about machines. They should be knowing about different kind of principles of special machines. So this video is only for machines. They also asked me certain other devices to be added, like transducers or other things. But that video would be different. And in this video only, we will communicate. We will only study about the different type of machines, whether it's AC machine or DC machine, and definitely special type of machine also, because we have special type of machines also, which doesn't classify, or which doesn't segregate as AC or DC machine, because they have a different principle. And in this video, we will discuss about different type of machines and their principle, their applications, and how they're different from other machines, right? So I'm a teacher, mentor, guide, Dr. Kamalkant Sharma, again in front of you. So we will start now without wasting much time now for the machines. So before I start, we should understand what machine is. Don't go for the Three Idiots scene for the machines, but we have to understand what actually machine, what the principle is, right? So let's start first with the DC machine. So what DC machine is all about? See, in front of you, like as I written over here, DC machine. So DC machine are the machine which are taking a supply of a DC. So one thing should be very clear in your mind whenever I'm saying DC machine or AC machine or any machine which is having a different type of induction. So when I say induction, it is your AC machine and the supply would be AC supply. But on the other hand, if I say DC machine, so the supply would be DC and the principle would be different. So that need to be clear before I start lecture. Now, see this in lecture objectives, we will go with the construction of DC machine. And we will also go with the basic construction of a DC machine. Okay, the principle of DC machine, and we will also go through words principle of DC machine and familiar with the control of DC machine. So we will also this are contents: introduction of DC machine, construction parts, function of commutator, function of armature winding, types of armature winding, function of brushes, and working of DC motor. Let's start with DC motor. This is your DC motor. As you can see, there are two different types of motor: DC motor and AC motor. But before, in the previous video, might you see that when I was discussing about DC and AC circuits, might you are aware that I discussed that we are having two directions, clockwise and anti-clockwise direction. So the positive polarity or the negative polarity. So when I'm talking about clockwise direction, I'm talking about motor. When I'm talking about anti-clockwise direction, I'm talking about generator. No, that is totally wrong. When I'm talking about generator, it is a clockwise direction. When I'm talking about anti-clockwise direction, is generator. So both can be replaceable, both can, because their construction is more or less same. And when I'm talking about DC motor, you can see in front of you the pictorial view of DC motor. In this pictorial view of DC motor, you can see we are having open windings. No, we are having closed windings. In DC machine, we are having closed winding. In AC motor, we are having open winding. That is the one way. Then you can see we are having a shaft, that is because motor requires shaft. Very basic. I won't go so much deep into it, but just try to give you an overview of the same. So for a rotation, we require a shaft, as you can see, and we require a shaft. We require windings, and we have two types of winding: armature winding and field winding. Which is more inductive? Field winding. Armature winding is less inductive as compared to field. If I talk about your the resistances, winding resistances, so if armature resistance 0.1, then the 10 times would be field winding, or 100 times would be a field winding. That is the relationship for the speed control of the machine. So as I said, DC current motor converts electrical energy into mechanical energy, and this question is asked in many interviews, and this need to be clear. Okay, so DC motor is basically converting your electrical energy to mechanical energy, and what it uses? It uses electricity and magnetic field. Please understand, it uses electricity and magnetic field. Magnetic field would be generated because we are using permanent magnets. I already told you we are having two different type of magnet: permanent magnet, temporary magnet. So in machines, we will use permanent magnets. So they will use electricity and magnetic field to produce torque, which turn the rotor and has a mechanical work. The 7 parts, 10 parts, 7 are very, very important. On the right hand side, it is having some problem. Magnetic frame, yes, outer part of the machine, yoke. Then we are having pole core, which is near your poles. Then magnetic field exciting coils, then armature core, armature winding, a lap winding, wave winding. They are the two different what I can segregation of armature winding. Then we have commutator, we have bearings, end ring, and shaft. So when today in this video, we will discuss all the machines, all the construction parts, and their working. When I talk about wave winding and lap winding, it depends upon the parallel paths. If your parallel path is fixed to 2, we will say it's wave winding. If it is equal to number of poles, it would be a lap winding. So lap winding is for big machines and wave winding is for smaller machines. Now let's see construction view of DC machine. You can see the construction view of DC machine. You can see armature winding, and this is the stator. You can say stator, you can say armature. It is because in induction motor we will say stator. We are having pole shoes, field winding, and then armature core and bearing shaft would be there. Commutator is basically converting from DC to AC and AC to DC, respectively. Right. So this is your construction of DC machine. Whenever any question is asked, you have to draw this construction view of the DC machine. Overview of DC machine. This is somehow you can better clear down. Now you can see we are having a stator. In the stator, we will have brushes with a commutator, because whenever the AC and DC would convert AC to DC or DC to AC, there would be a sparking. For this, we require brushes. Axle, it's a rotating part, and we are having a rotor the both sides. As you can see, the field magnets are being placed. Now, if I talk about overview, you can see there is a rotation, the field rheostat with which we can change the value of resistance of the field winding. This is frame, the outer part of the body. This is armature conductors, right? Commutator is just near the armature conductor. Interpoles and your compensating winding is to improve the magnetic field. That means armature action should be minimized. What happen actually? Whenever you're giving a supply, it won't be constant, won't be uniform. So we have to make it uniform. And for that, we require certain kind of auxiliaries. And these auxiliaries are nothing but interpoles and compensating windings. So as I already told you, a magnetic frame or a yoke is the outer part of a machine and supports a pole cores and provide mechanical protection to the inner parts of machine and provide low reluctance. So two different purpose of your magnetic frame or a yoke. The first is basically to providing a low reluctance path, and second is providing mechanical protection. And I'm talking about pole core and pole shoes. You can see they're basically fixed to the magnetic frame, okay, through bolts. Why so? Because if you remember in the previous video when I was discussing AC and DC circuits, I was discussing transformer. In that transformer, we discussed that we are using not a continuous path. Why so? Because we have to reduce eddy current losses. So this pole core and pole shoes are made up of cast steel or wrought iron. Again, objective is to support the exciting coils and to increase the cross-sectional area of the magnetic circuit. Then having a field or exciting coils, you can see these are enabled. Enabled copper is covering a copper with some kind of lamination, some kind of part. These field coils are connected in series so that the current can flow through it, and adjacent poles can attain the opposite polarity. That is because if magnets are not getting opposite polarity, they won't rotate. Armature winding, yes, is very important. Insulator conductors are placed in the slots of armature core. Armature winding is basically heart of DC machine, because if it is not there, the flux won't be produced. Because over here we are also dealing with Fleming's law. If you remember, in the previous video we discussed about the Fleming's law. We also discussed Faraday's law, in which we said whenever the current carrying conductor placed a varying magnetic field, and EMF is induced. So over here we can say lap winding and wave winding. So I already discussed whenever the lap winding is equal to number of poles, it is used for big machines, large machines carrying heavy current. Even in the wave winding, it is for the small machine carrying less current, and it is fixed values too. Commutator, which is basically rotates with armature, so it is in line and it is cylindrical in shape, right? And another thing that it induces alternating current into armature conductor. So I already told you it converts unidirectional current into bidirectional current, or bidirectional current into unidirectional current. And this is important when it converts alternating torque into unidirectional torque, right, in the motor action. Brushes, you can see I use different fonts because brushes and end housing and bearings are all three are different in nature. Brushes are basically pressed upon the commutator, and it's a connecting link between the armature winding and external circuit. On the other hand, end housings are connected to the mainframe and support the bearings. But bearings are like Garari, right? And might you see that in some bikes or in some automobiles. This is the bearings function is to reduce the friction between the rotating and stationary part of the machine. Shaft, you know very well, it is made of a mild steel. It is required of a mild steel. Mild steel with required hardness. Mild steel is basically having some amount of carbon into the steel so that its hardness can be increased and it can be used for transferring mechanical power to the from or to the machine. Now let's talk about that was construction part of DC machine. Now let's talk about working principle of DC machine. A machine which converts DC electrical power into mechanical power in DC current motor, and its law is Fleming's law. Whenever current carrying conductor plays a magnetic field, it experiences a mechanical force. I'm not saying it is EMF. EMF is induced in the case of Faraday, but the direction of this force is the Fleming's left-hand rule. Remember, for a generator, let me see my expression. For Fleming, for generator, it will move like this, Fleming right-hand rule, and for motor, it will move like this in an anti-clockwise direction. So Fleming right-hand rule is for generator, and Fleming's left-hand rule is for motor. So Fleming's left-hand rule, as you can see, whenever the current carrying conductor placed in a magnetic field, through a magnetic field, the magnetic force produces a torque that turns the DC motor. So what we studied now, we studied DC motor and construction, working principle, function of commutator. These are very generic questions that can be asked in any kind of paper and competitive exam, right? What is the principal operation of DC motor, commutator, function of brushes, lap and wave binding? So these are the normally questions that can be asked. So I hope everything is clear. If any query from the construction part or the principal part from the DC of the DC machine, you can write in the comment section, right? So we will talk about the DC motors, yes, but the characteristics of DC motor are very, very important. Right, so we will discuss the characteristics of DC motor. There are three different characteristics what we have. We have torque speed, we have torque current, we have speed current. So these three characteristics are very, very important in every kind of motor, whether in induction motor, it would be torque slip characteristics. Okay, but over here, we are only going to deal with the three characteristics. They are basically DC motor characteristics. I hope this is clear. Please let me know. If anybody having any kind of issues with the principle or construction of DC machine, yes, the principle and construction of DC machine, if somebody is having any kind of doubts into it, please. Otherwise, we can start with. We can start with the characteristics of DC motor. So we are going to start with now characteristics of DC motor. So when I talk with characteristics of DC motor, as I already told you that we are having three different characteristics of DC motor. Right, and we in the previous topic we discussed about what I can say, the construction and the principle of DC machine. Now we are going to discuss with the characteristics of DC motor. So when I talk about characteristics of DC motor, we are talking about three different characteristics, and this is speed current. This is your what I can say, speed torque and torque current. So these three characteristics we will study in this topic. So let's start now. So this is characteristics of DC motor. In this characteristics of DC motor, we are talking about the contents, various types of characteristics. As I told you, torque current, and torque speed characteristics. So there are three different characteristics in which we are going to deal with. You can see we are having torque armature current, speed armature current, and a speed torque characteristics. For a DC motor, we know very well. There's a very important formula. Please note it down. Torque is equal to phi I Z PZ upon 2 pi. 2 pi. So what is constant value in this? We are having A is constant. What is A? A is number of parallel path. Z is nothing but number of conductors per pole, and P is number of poles. Right? Is this okay? Please let me know. So that is Pz upon 2 pi. That is your main number of parallel paths, in which we will discuss the number of parallel paths, and Pz upon 2 pi. So you can say 2 pi is constant, Z is number of conductors per pole, P is the number of poles, Ia is armature current. So we can say it is T is directly proportional to phi Ia, flux into armature current. This is very, very important. Please note it down. You can see lap winding, as I already told you, the coil 1 and coil 2 are being connected, and in wave winding, we will have a different wave windings in which we will have different amount of, we have only two coils, but in this we are having multiple coils. So, right, so torque speed equation again, you can see the EB is equal to, again note it down, EB is equal to 5 Zn by 60 into Z into P 60 by A. So 60 again, right? 60 is constant, A is constant, what is left? Phi n. So you can say n is equal to EB upon phi. The EB, that is important, please understand, EB is nothing but, just keep it, input is equal to output plus loss. In a mechanical, in your motor, what is your input? You're converting electrical to mechanical. What is the input? V. What is the output? EB. So V is equal to EB plus IARA. Please note it down. Okay, so we will come across n is proportional to EB upon phi, right? And we can easily control the speed once we have the voltage and current. So you can say EB is equal to V minus IARA. This is that equation what I was talking about, V minus IARA upon phi. So on the basis of these two equations, we will see the characteristics. Now let's talk about first characteristics, torque, armature current characteristics of DC shunt motor. As I told you, we are having three different types of motors. One is DC shunt, one is DC series, one is DC compound motor. Shunt motor, in which the field and armature winding are in parallel. Series, in which the series armature and field winding are in series. And compound, in which the flux will decide that it is a differential compound or cumulative compound. If the direction of the field and armature winding are opposite, it is differential. If they are same, it is cumulative. So you can see that in this, in DC shunt motor, flux IA, and flux is constant. Yeah, right? The flux is constant in shunt motor because voltage is constant. Voltage is constant, flux would be totally automatically constant. T would be proportional to IA, you will get a linear graph. Even though, if I talk about DC shunt motor in the case of speed armature, you can see shunt motor cannot start with load. We have to start shunt motor without load. Okay, so you can see we will have a linear characteristics but downward. Similarly, speed torque characteristics, it is again inverted graph of decision. But on the very hand, if you talk about DC series motor, you can say because the voltage won't be constant in series, so it would be T is equal to IA square. So when it is IA square, you will get a parabolic graph. Again, you will get a parabolic graph in the case of speed armature current characteristics. In the speed torque characteristics, again the similar kind of graph you will obtain. The only difference is maximum value is not attained. These are characteristics with DC compound motor. Two types of compound motor, as I told you, differential compound or cumulative compound. If the direction of current is same, it is cumulative. It is opposite, it is differential. Right? So we basically in cumulative compound motor or compound motor, we require both characteristics, series and shunt. Series winding takes care of heavy load, whereas a shunt motor prevents a motor from running at dangerous speed. So these two characteristics are required for any kind of motor. Differential compound, normally we don't use it because it is very dangerous on full load and it can attain very high speed. You can see all the three characteristics in one slide that I made only for you. You can see where the shunt, where the series, where the compound. So if any question comes, you can draw all the characteristics in one graph only. Application of DC motor, it is used in blowers, fans, lathe machine, machine tools, drilling machine, punches, and elevators. So this is how the DC motors are being discussed. That we discussed in the summary. And these are the questions that can be asked. Classification of characteristics of DC motor, draw the torque speed characteristic DC series motor, design the torque armature, and application DC motor. So with this, we are done with the characteristics of DC motor. Anybody having any kind of query, you can write in a comment section. Thank you. Yes, students, I hope you are able to get it. You're able to hear me up properly, right? So we are going to discuss BLDC motor. So when I saying BLDC motor, if you remember in the previous topics, we studied about DC motor construction. We studied about the principle of DC motor. We studied about the characteristics of DC machine. Now this is a special type of motor. Before I move to induction motor, before I move to AC motor, let me discuss about BLDC motor. This is a very, very important motor, what I can say, right? And this BLDC motor definitely will work out. And the name is brushless DC motor. So it's a DC motor only, but it's a special type of motor. Why I'm talking about a special type of motor, you will see in this video, because in this video, we will talk about special machine and induction machine also, right? Yes. So let's start now. I'm your guide, mentor, teacher, Dr. Kamal Sharma. Let's start. We will have a BLDC motor. Now, what this BLDC motor is all about? BLDC motor is basically brushless DC motor, which is taking care of all the things. And the contents is basically introduction of BLDC motor. We will go with the BLDC motor introduction. Then we will discuss the main parts of brushed motor, classification of brushed motor, working principle of BLDC motor, and application. That's our contents on which we will talk about. So you can see that we will talk about BLDC motor. The permanent magnet, first of all, it is permanent magnet. I already told you no motor is having a temporary magnet. Every motor is having a permanent magnet. So we are having a brushless DC motor, which is having a permanent magnet and generated by the virtually inverting the stator rotor. Please remember this, we are having a Hall effect sensor into it. So permanent magnet bonded to the rotor, right? Bonded to the rotor, not stator, bonded to the rotor, and Hall effect sensors are there. So basically they are generated by virtually inverting the stator and rotor of PM DC motor, right? So these motors are actually fed by rectangular AC waveform. So one thing is very clear, they are DC motor, no doubt, but their input is rectangular AC waveform. That's why we are using a Hall sensors. The advantage of this, the removal, that we are removing brushes. Brushes we are removing, that means we are removing commutator also. And we don't have any kind of sparking into it. We don't have any kind of sparking into it. So whatever the problems we were having, because the brushes were made up of carbon, so whatever the problems we were facing with the brushes, we try to eliminate. These classical DC motors are very good. They're simples, but they possess very good control characteristics, although, and they're very good enough. But they were having some kind of problem with the brushes. So this motor is basically to overcome the limitations whatever we faced in DC machine. So main parts of brush DC motor is, you know, that commutator and brushes, which we removed it. In brushless DC motor, we are having no brushes. You can see brushless DC motor, we are having coils, 3 magnets are there, right? And the magnets are being placed. We are having ESC battery. And this is a very beautiful diagram, what I got it and I placed it for you. So we are having ESC battery, we are having magnets, and these magnets are being connected. We are having a coil. So they are detected by the Hall sensor mounted on a rotor shifted to 60 degree or 120 degree, depending on the type of rotation you are having. So you are having a flexibility, that how these can be mounted on rotor and how this can be seen, right? So has no brushes, first of all, no commutator. Rotation of rotor depends upon the accurate position with the stator. It can be 60 degree, 120 degree. We are using rectangular AC waveform, so we will go with the PWM. PWM is pulse width modulation, and they can be controlled. Their speed control can be done by using software. With no commutator, the current reduction of the conductor depend on the state controlled electronically. So rotor consists of the permanent magnet, and whereas the stator has a number of windings, it can be lap, it can be wave. But this current through the winding produces magnetic field and force. So as a no commutator, the current touches the conductor depend on stator and can be controlled electronically. So rotor, what are the important things? Rotor position has to be very accurate. Hall sensor has to be sense the position of the coil accurately, and DC motor requires external commutation circuit for this. What is commutation? For converting AC to DC, right? So application, permanent magnet BLDC motor, we use in domestic application, we use in automobiles, we use in automatic cars where the gear system is not there, public life application, transports, healthcare equipment. So there we use this kind of machines, right? And this a question can be asked, explain the operation of geared motor, operation of brushless geared motor, and the different types of brushless DC motor. So one thing is very clear, whatever the limitation we faced in DC machine, we try to overcome. And this can be only overcome if we are not using brushes and commutator. In certain cases, yes, we are providing the commutation circuit externally, but anyhow, we removed the brushes. That is the most important thing in this. And the second part, I just want to summarize. The second part, which is important in this brushless DC motor, and we are providing the rectangular AC waveform, so that it can be controlled electronically. I hope this is clear. Yes. Thank you. Thank you. We will study about Now we will study about induction motor, and this induction motor is very important machine. In 90% of the machines uses DC uses induction motor. Even DC motor is also very good. It's very rugged, but induction motor having very good application. So we use to have induction motor. Even in your fans, in your domestic appliances, we are having induction machine and single phase induction motor and three phase induction motor. Depending upon the single phase and three phase, if the supply is single phase, then naturally it's a single phase induction machine. If it is supplies three phase, we will talk about three phase induction motor. So this is a very important thing that we need to understand. So let's start about induction motor. The characteristics, what are important induction motor is torque, slip characteristics. Over here we talk about torque speed, we talk about torque slip. What is slip? You will study over here, but in very brief, there is a speed of stator also. Ns is equal to 120 f upon p, and there would be slip, that is nr, speed of a rotor, and the difference between both of them is decided by slip. So maximum amount of slip that is allowed is 4%. I'm again repeating, please note it down, 4%. If it is not given in any kind of the question, you can use it 4%. If it is given, then you can use it, right? So let's start introduction to induction motor. What induction motor is, you can see we will study in this content: introduction single phase induction motor, basic construction, advantage, disadvantage. There are two type of rotors. On the basis of the name is given, scale cage and slip ring. So when I talk about scale cage, scale is basically Gilhari and cage is Jungla. So with the name of this, we are having a scale cage induction motor. They will provide a path from stator to rotor. Okay, and we are having a slip ring induction motor. So working principle is very clear, single phase induction motor, and we will discuss applications, introduction of three phase induction motor, advantage, disadvantage, and application. So let's see the pictorial view of single phase induction motor, and you can see that we are having a D end. In this, you can able to see stator winding, you are able to see rotor, you are able to see an end, and cooling fan is there. You can see it's open winding, whereas DC was closed windings. So single phase induction motor means it does not have any self-starting torque. Please understand, single phase induction motor don't have self-starting torque, and single phase supply is being used. That's why it is saying single phase induction motor. You can see end shields are there, stator is there, rotor is there, frame is the outer part of the body, motor shaft. So it's type of DC motor. It works on single phase AC supply used in small toys, small fans, hair dryers. If I talk about single phase induction motor construction part, you can see that we are having our two main parts, stator and rotor, right? And which is moving, it is known as rotor, which is not moving, it is known as stator. Stator part is basically in the known as that is made up of some kind of lamination and stampings, and it is wounded, so it does not run on synchronous speed, right? But why it is not run on synchronous speed? Because there is a difference between stator and rotor. Otherwise, the stator speed is nothing but synchronous speed. Types of rotor, scale and wound rotor. You can see it is a matter very rugged, very good construction, and very good, having a very good efficiency. Whereas laminated core, we are having a wound rotor, we are having a coils, and with the help of resistors, we can able to control the speed of a machine. Scale cage motor which hardens electromagnetism, right? Scale cage one of the types of induction motor. So it hardens electromagnetism. Output is connected to the inner component, which is looking like a cage. That's why the name is given scale cage. And avoid hysteresis or radical losses, the rotor is laminated. Advantage of scale cage: low initial cost. Please note it down: low initial cost, high starting current is a disadvantage, and low power factor. Whereas the application we use in centrifugal pumps, 90% of the machines are having this scale cage rotor. Slip ring rotor is only required whenever you require speed control. Otherwise, slip ring rotor is not used. In scale cage, there is no flexibility of having a speed control, but yes, in slip ring we do have. So you can see that at which operate not equal to synchronous speed. So we have to just control the speed of a machine, and for that we are using a slip ring induction motor. You can say we have having a slip ring that is mounted with a rotor core. Advantages: high excellent starting torque and low starting current also. But yes, what is the disadvantage? It is having a very what I can say construction which is very complicated. So we require brushes also, and that will lead to sparking. So these motors are used where high torque and low starting current are used in elevator, cranes. If I talk about rotor, it is a rotor wound type and slip ring. Scale cage is scale cage type. Rotor slot cylindrical core, but a scale cage is not parallel. Construction very complicated in slip ring. It's a simple construction. So external resistance can be added. Actually, it is required. Efficiency is low. Scale gauge efficiency is high. Now let's talk about the last topics that we are going through. Working principle of single phase induction motor. Single phase supply is given to the stator supply, so it will carry alternating current. So whenever it will carry alternating current, it produces a flux, right? And this flux is known as main flux. This flux will link with the rotor conductors, right? And the EMF get induced in the rotor, right? And this EMF, induced EMF, drives to the rotor as the rotor circuit is a closed circuit. If I talk about single phase, again, flux, rotor flux, motoring action is required. Similarly, as you can see that in DC machine, the armature flux is required. So that is the important difference between DC motor and induction motor. In DC motor, separate supply is required to the armature to produce armature flux. Even in the case of your induction machine, we are giving a supply to the stator. And whenever you are giving the supply to the stator winding, the stator winding will carry an alternating current and produces a flux. Single induction motor use refrigerator, air conditioner, vacuum cleaner, washing machine. Now let's talk about three-phase induction motor. As I already told you, we are having two different type of machine. One is single phase, one is three-phase. So now we're talking about three-phase induction motor. This three-phase induction motor is very, very important. It is basically used in all the industrial drives. Very reasonable, very rigorous, does not run at synchronous speed, very high overloading capacity. Right, alternating current, three-phase supply means three phases are given, right? Red, yellow, and blue, RYB. So these type of motor is known as self-starting. Induction single phase are not self-starting, right? The principle is exactly the same. The stator, which is made up of high-grade alloy steel laminations, right? Scale gauge motor is laminated steel core. Normally, each slot contains uninsulated bar conductors. Slipper induction motor, again, it's a cylindrical core, right? Outer periphery has a semi-closed slot so that resistances can be added. So let's talk about working of three-phase induction motor. So whenever the three-phase supply is given to the motor means stator. So the resulting current generates a magnetic flux. Clear? That is phi. Due to this switching sequence of R by B, the generated flux rotates around the rotor conductor. So whenever it will rotate, the Faraday law states the EMF would be induced due to the rate of change of magnetic flux. So that is EMF is induced in the copper bar and the current flows in the rotor. Similarly, the direction of rotor can be decided by the Lenz's law because the negative direction, if you remember in the first video, I shared with AC and DC circuits in which I discussed detailed Lenz's law that E is equal to minus N d phi by dt. Right? So relative velocity between the rotating flux and the static rotor conductor is the cause of current generation, and the relative velocity is rotating the rotor of the induction motor. That is very, very important. Please note it down. Ns, synchronous speed. Ns is equal to 120 F upon P, where F is the frequency, P is the number of poles. This is the percentage of slip. If it is not given, then we can take the value of slip is 4% maximum. Otherwise, it is Ns minus N divided by Ns, where Ns is nothing but your synchronous speed and N is a rotor speed. Sometimes it is given, sometimes it is not given. Then you can calculate with the help of slip. Please note it down. This rotor speed is given by the equation Nr is equal to Ns 1 minus S, where Ns is the synchronous speed and Nr is the actual rotor speed. Frequency of the rotor. Normally, when I'm talking giving a frequency F, that is the frequency of the stator, but you can also calculate the frequency of the rotor as Fs. Fs is the frequency of the stator. So if the slip is equal to 1, whenever the slip is equal to 1, when it will happen? When we have a motor at a standstill condition. Remember this, please note it down. Advantages, there is a rugged and harsh environment, sea-going vessels. Yes, we are having so many disadvantages also. Now, what are the disadvantages? Speed control of three-phase induction motor is difficult. Application we use in large capacity, engine blowers, fan motor. Friends, you know very well, single phase means single phase supply, three phase means three phase supply. Three phase difficult to repair, single phase are easy to repair. You are using in fans also. Efficiency is less in single phase because it's not a self-starting machine. Similarly, you can see power factor is low in the case of single phase. Okay, three-phase induction motor is quite expensive, and what we studied, you can see it. Construction of single-phase induction motor, difference between scale case slip ring, and three-phase induction motor. Right? So this we studied with the help of induction machine. So now I hope everybody aware that what is DC machine, what is induction machine, how they are different from each other, and how they are going to use in certain applications, and depending upon the requirement. Right? Write your comments. How you're liking the video, how you're checking the video, did you like it or not? So you can mention over here, right? And you can also, I'm changing the format of the PPT side by side. So you can also mention it whether you're checking, knowing the or liking the PPT format or not. Okay, so it was just a break because we are going to close the machine now. That's the last topic in machine. Then we will make another video on transducers because most of the student also asked about the transducers. We want to know because they are using three-phase triaxial sensors, and they are because transducers are very important in making a project, right? So whenever you are making a project, these kind of things are very, very important. And I will make a special video. That's why I said that I won't mix with the machines. I will make another video on the transducer, and it would be very helpful for you. Sorry. So let's start now. We are closing the machine topic. We are beginning with the gear motor. And these are the gear motors. You can say servo motor, stepper, and linear motor. So these four motor we will cover in this topic. And I'm actually, if you want different videos, I can separate them, but that's why I'm making different videos, right? And these videos would be merged together so that it would be easy for you, one go. Okay, otherwise you can tell me, I can divide these videos. So gear motor, servo motor, stepper, and linear induction motor. So we will go with that. So these are the contents. And when I say linear induction motor, these are very, very important because nowadays we are talking about not rotational part or circular part induction motor. We are talking about linear induction motor. What is gear motor? Now let's see. Gear motors, as you can see, it's a complete motive force system. When I say motor, motive force system, we are providing. What is gear? When you are going at a fourth gear, your speed is maximum, right? But as soon as you can control your speed by reducing the gear, similarly, it's it is electric motive force system consisting of reduction gear system and electric motor, so that it's a package basically, right? So and you can see that it will reduce the cost in making some special arrangement of controlling the speed of a machine, right? So this gear motor is specifically having or producing a high torque at very, very low speed, right? Which is not possible with DC or induction machine. That's why I'm saying it's a different type of motor. As you can see, 1200 RPM, 3300 RPM. So you can see there are four is to one ratio, 3 is to one ratio, but normally we go with one ratio. So basically, gear motor principle, if you talk about, if we have a range of 1200 to 3600 revolutions per minute, and they would have both normal speed and stall speed also. Normal speed like a simple motor, and stall speed like if you are talking about some kind of gears, some ratio speeds. So these are used in some trains, some kind of it's kind of a mechanism of a speed control. So don't consider itself as a is a special motor only. It is a different mechanism which can be connected with a different motor for controlling a speed. Okay, so as soon as the torque will increase, the speed will go down. So reduction gearing allows small electric motor to move large driven loads. Reduction gear, small gear driving a large gear, several set of reduction gears and reduction box. So they are having three different types of gear motors, or you can say a mixture of because bevel and worm are basically one, but if you classify, then it can be four: helical, shaft, bevel, and worm. First is basically they are available in gear mechanism. They are available in non-lubricated metal gear mechanism, so no requirement of this, and they can provide speed reduction anytime by providing a gear. So these are features. They can go against overload. They can use for reversing and dynamic braking. So main aim is basically to control. So there is no need to go in detail about bevel mechanism and all. Yes, they are using power drills where the speed control is required, right? There we use a gear motors. I'm going very brief into it, right? But yes, these are very, very important. These can come in your question paper. This can be asked in interviews also. So what is the meaning of servo? We are having a servo mechanism or servo motors. What this servo motor is all about in modern usage, this is very, very limited. Okay, because we require feedback control system for this servo motors. Why so? Because we require some controlled variable, which is a mechanical position or time derivatives, so that we can control the velocity and acceleration. So servo is a basically a device. It can be electrical, it can be mechanical. It's a combination of electrical and mechanical. It's electromechanical, and where the input will imply feedback. So feedback will drive your input, and automatically the output can be controlled. This is the Z construction of servo motor. You can note it down, in which we are having a motor along with the gear system for the reduction in speed. Then output shaft is there. But with this, before the output shaft, we're having a potentiometer, which is basically controlling, calculating a voltage, and will give an error signal. If there is some error, that would be amplified, that would be reduced and given to the motor, so that the motor can, uh, you know, uh, can change its speed control, and we can obtain a desired output. So three major parts we will have in servo motors: control device, feedback system, and output, right? Output sensor. So sensor depend whether it's Hall sensor, whether it's IS sensor, whether it's any other sensor. It depend upon the kind of application, right? It's a closed loop system first of all, but over here I want to emphasize the open loop systems are more stable as compared to closed loop system. So this controller is composed of comparator and a feedback part. So we are producing an output signal. The comparator is used and will compare with the reference signal and the output signal, then the input signal will be given as a feedback signal. So the motor can control that I talked to you in the previous slides. Advantage: high output power relative to motor size, high efficiency. It can rapidly accelerate, reserve power 2-3 times continuous power for this. Reserve torque 5 to 10 times. Rated torque for the short motor stays cool. These are the wonderful advantages we will have. Disadvantage, yes, because it is required. It is a complicated system. We require feedback. Peak torque is limited to a certain percentage. We require certain ventilation. So that's certain disadvantage. But if we used these servo motors nowadays in DVDs, it is now absolute. But we were using in disc players, we were using in hydraulic system, they are absolute. So nowadays servo systems are very hardly used in various applications. Last one, second last one is stepper motor. Stepper motor is an electromechanical device which converts train of pulses into a mechanical movement. So you can say we are converting pulses into a mechanical movement. So this shaft is fixed. Okay, it can be linear, angular, depends upon the kind of motor. But the train of pulses. Now there's a difference between pulse and a wave. Pulse, when we talk about ECG, it's a pulse. It's of a certain frequency, fixed frequency. So it gets to a certain angle, right? So at an angle which at which the stepper motor rotates is known as step angle. So you can see that working on stepper motor, there is some disturbance. Please bear with me. So we are having a stator and rotor. So in this, this angle will rotate. This angle will rotate and make a shaft also rotate, right? So we are talking about operation of stepper motor. Each of flight operation is a step in which integral number of steps making a full operation. Okay, so stepper motor doesn't rotate continuously. They rotate in a step. 4 coils, 90 degree, 360 total overall. Okay, 90-degree rotation with a step. If you talk about working, so one thing very clear, I am again repeating, it is a permanent magnet. No machine is having a temporary magnet. Every machine is having a permanent magnet. So whenever the current flows through a stator winding, it produces a vector magnetic field. The other name is known as vector motor. The other name of stepper motor is vector motor. So this magnetic field will drive the rotor to rotate by a particular angle so that the direction of stator are consistent. This angle will decide the rotor rotate with the magnetic field with that angle, and it will decide each time the electrical pulse will be given and it will go on, right? So we can control the rotation of stepper motor by only controlling the number of pulses, right? Otherwise we are not able to, because pulse is having a certain fixed frequency. So there are three different types of stepper motor we have. One is variable reluctance, one is permanent magnet, one is hybrid stepper. I'm not going to so much detail into it, but you know very well permanent magnet means it will have permanent magnet first. Second, it will work on the principle of attraction or repulsion. Third, the stator winding will produce are excited with the DC coil, so we will require DC and AC supply both. And due to the force of attraction, this will move on. In variable reluctance, as you know, variable reluctance is just the opposition to the flux. So it is a variable reluctance. That means the air gap would be non-uniform. It will have non-uniform air gap and minimum somewhere maximum air gap, and so that this reluctance would be there, and the flux value of flux would be different. On this basis of this, the other name of this motor is multi-stack motor. The third motor we are having, hybrid stepper motor, is a combination of both, that is permanent magnet and variable reluctance. And this motor is used because we are having a rotor disc and having a lamination. So what are the stepper motor advantages? See, if the bearing is good, motor is good. Right, one thing. The motor has full torque standstill. That is very, very important. Maximum torque, you can say. Because no deviation is there, because it is controlled by the number of pulses. If the pulses are good, the torque is good, the speed is good, it can achieve low speed and with a load that is directly coupled to the shaft. Okay, we have only one disadvantage. It is not easy to operate very high speed. First of all, it cannot achieve high speed because it is controlled by pulses. Second, resonance can occur because you are making a machine with an angle. So application, we are using this machine in an automated machine. We are using in some satellite navigation system. We are using in photography machines. We are using in some cameras. So this is stepper motor application. Now, last motor we are targeting now, linear induction motor. The other name is linear induction motor is LIM. So when I talk about linear induction motor, it can achieve rectilinear motion. Rectilinear motion is with a combination, right? So as you can see, it's a special type of motor which is placed horizontal. You can see this is placed horizontal, and we are having a stator and the rotor in between, and the coils are being provided. So this kind of motor is for a special purpose. Then its versatility is increased. So if I talk about construction of linear induction motor, it's similar to three-phase induction motor exactly, but it produces a vector field. So it's not it is not a conventional induction motor, first of all. And second, we cut the stator of this induction machine into a flat surface. So the primary of induction machine is a flat surface. Similarly, we cut the rotor of the induction motor and make it flat. So secondary is again flat. So that means we are increasing our efficiency. How we are increasing? Because there is no eddy current and hysteresis losses, because there is no circular part attached. So we are having double-sided linear induction motor also, right? So that means we are converting. So primary of LIM, you can see that that's the primary of LIM. That is basically dealing with the wind into it. It interacts with the traveling flux. Okay, thrust. That is by giving with a mechanical input. So LIM get excited by a balanced three-phase supply. It is very much required. We cannot afford non-balanced three-phase supply, right? And relative motion between the traveling flux and the conductors. So this is the formula of V is equal to 1 minus Vs. It is exactly the same if you see it. Instead of V, it was N R rotor speed. Now we are having a voltage of the rotor, and Vs is the voltage of the stator. Applications, we use this kind of machine in automatic seating doors, sliding doors, electric trains, mechanical handling equipment, propulsion, conveyor belts, handling in the cranes. These are some application, and these are the question that can be asked, that why servo motor is used for feedback system. Because if it is not used for feedback system, then how you can get a desired output with respect to changing input. Second, how many different type of servo motors we have? Three different types of servo motor you have. Variable reluctance, we already discussed in detail. Discuss the application of servo motor, we already discussed. Variable and hybrid stepper motor, discuss the application of stepper motor, that we already discussed. So these are the questions that can be asked from the special motors. So this is all from the machines. So I'm closing over here with the machine. So that what we discuss in this video, we discuss about the DC machine. We discuss about the induction machine, construction and principle both, their types, their characteristics, special machine, geared motor, stepper motor, linear induction motor. We discuss in detail the special machine also, and the principle and their working and the types, right? So this is all from machines. Any kind of comments, any kind of doubts you have, comment in write in the comment section, and comment definitely, so that I would be more than happy to resolve your query, right? Thank you very much, and have a nice day.